It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Yes, now please take it. Am I audible? Once kindly check. Yes, am I audible, right? Thank you. So let's continue now. Okay. So guys, now see here. On last Saturday, I have taken a session on practice session for your AE JE examinations for TSSPDCL and other examinations for all the states. In fact, electricity examinations, AE JE exams के लिए that will be helpful. So many students who are aspiring for TSSPDL, they have the examination on 17th. those people requested me, so take at least one session every single day, such that it will help further preparation. Yes, definitely, I'll take one session every single day, which can help for any students who are aiming for AEJ examinations. And for you people, as you have the exam on 17th, definitely every single day, I'll try to take one session completely, at least on YouTube or special completely free session compulsory. Okay, don't worry, I'll be supporting you up to your examination. So today's session, I have planned 13 questions. In these 13 questions, I have selected very good questions, a few questions from analog circuits, I think 3 questions from diode circuits and 3 questions from digital circuits, and the remaining questions from network analysis. So I tried 3 different subjects, I mixed and taking the session today. Okay, so now this is about me, this is my profile, this is Bhima Sankar. I did my MTech from IIT Kharagpur. I have 11 years of teaching experience in GATE and ESE throughout the country. I'm expertise with the subjects of digital circuits, network analysis, microprocessors, computer animation, and also I'm starting analog circuits from this month on Unacademy Plus platform. So this is about me. I'm able to guide thousands of students like you in the past 11 years. I'm very happy to help you in all the aspects of your preparation. So guys, regarding the Plus subscription, if you take an Academy Iconic subscription, you will be getting this advantage, like you can get one-to-one mentorship program where you will be getting a chance to take the live sessions based on your subscription duration. You will be getting 2 sessions per every month. Okay, and these are the facilities you will be getting if you take subscription, like top educator classes, doubt clearing sessions, study notes, and test series you will be getting for free, whichever required for your preparation. So if you need beyond this, if you want to go for personalized guidance, you can go for Iconic. इसमें आपको physical notes मिलेगा, strategy study program, one-to-one mentorship, you will be getting it. Okay, if you have some financial difficulty, you can call to this number, you will be getting the loan for your subscription. Okay, you can also write daily scholarship for enhancing your preparation, guys. Okay, guys, so that's all. Now let's continue with the problems. Then we will discuss it further, remaining regarding the batches and all later. I hope it is visible. Just a moment. That's a good question. This is given in the exam TSSPDCL 2018. Okay. So ready guys, आप लोगों के लिए मैं तो टाइम देना चाहिए. एक मिनट हमारा स्टैंडर्ड टाइम. सो डिपेंडिंग ऑन द क्वेश्चन, मे बी 1-2 क्वेश्चन में मैं ज्यादा टाइम भी दे सकते. ठीक है. बारिश हो रहा है, सो आई वॉन्ट, आई प्रे सच दैट कुछ पावर कट कुछ नहीं होना चाहिए, क्योंकि इंटरनेट का कुछ इश्यू है. पावर कट हुआ तो नहीं होना चाहिए इस क्लास में. ठीक है, चलो लेट्स सी. हाँ, एक तो डायोड सर्क्यूट दिया एग्जामिनर, एक रेसिस्टर 30K का दिया. दे हैव गिवन वन रेसिस्टर ऑफ 30K. डायोड सर्क्यूट इज गिवन एंड ही हैज गिवन यू द डायोड वोल्टेज ड्रॉप ऑफ 0.7 and what will be the V naught. VDD equal to 10, VS equal to 5, then what will be your V naught? Option A 2.1, 2.9, 3.6, 6.4. Right. Okay, electrical engineers, I'll try, I'll check the source. Okay, the all are electrical engineers हैं, सभी का नाम सेम रखा क्या? निसर्ग, मैं तो रिप्लाई किया ना तुमको. ओके, यू जस्ट सी द चार्ट, आई हैव ऑलरेडी रिप्लाइड टू दैट. ओके, राइट, ऑप्शन ए सही है. ओके, इस क्वेश्चन पे ज्यादा आप वरी मत करना. सपोज इफ all diodes on, this is my way of solving the question based on my knowledge on network analysis. अगर सारे डायोड्स ऑन हुआ तो क्या होता है सर? ये तो 0.7, ये तो 0.7 देता है भाई. दिस इज 0.7, दिस इज 0.7. ठीक है, एंड दिस विल गिव मी व्हाट इज दैट 5 volts, एंड ये तो 0.7, ये तो 0.7, ये तो 0.7. It is impossible. Why it is impossible? It will give you violation of KVL. Why violation of KVL? ये voltage तो 2.1, ये voltage to 6.4, they cannot be in parallel. Okay, so this is not possible. So any one of the diode set will be on. Suppose if this part is on, you get 2.1. If this part is on, you get 6.4. Both are available in the options. But if this part is on, you will get here 5, 1.7, 0.7, 6.4. But that 6.4 will definitely turn on this because ये turn on होने के लिए यहीं पे 0.7 चाहिए, यहीं पे 0.7, यहीं पे 0.7 कितना चाहिए मेरा को इस नोड वोल्टेज, if this node voltage is more than 2.1, that is sufficient to forward bias all these three diodes. So if this is 6.4, if this is 6.4, compulsory it will forward bias this. So and so it is not possible to get 6.4. So what is the possibility to get the answer is 2.1. I am repeating, see here, if you take, if D3 D4 on, then you will get 0.7, 0.7, and this will be 5. But okay, this might be 10, leave it. But this, what is the voltage across V0 will be 6.4. But V0 is positive na. Your D1, D2, D3 cannot be a reverse bias. It is not a possible condition. If they want to reverse bias these three, they must be less than 2.1. If it is ideal, they must be negative. So compulsory this assumption is also wrong. So only one possibility. Directly dekh ke you can say it here. No need to waste your time also if you have enough practice. So compulsory D1, D2, D3 on is the only right answer. You get 0.7, 0.7, 0.7, total 2.1. This is your 10R and the diodes will be, this is the circuit. Fine. Chalo, one more question from the diode circuits. If you have any difficulty at any point of time, feel free to ask me. I'm happy to help you guys. Okay. So, right. Yeah, N log only, Arvind. Right. Chalo, let's see. The next question. आपके लिए next question ready है भाई? लास्ट टाइम 15 क्वेश्चंस के ज्यादा टाइम लगा है, सो इसलिए मैं तो इस बार 13 क्वेश्चंस लाया. ओके, सो लेट्स सी हाउ मच टाइम इट विल टेक. अगर हाफ एन आवर पे कंप्लीट किया तो हाफ एन आवर पे मैं छोड़ता हूँ. इफ इट टेक्स मोर टाइम आई मे टेक मोर टाइम. चलो लेट्स सी. Can you repeat the second case, Rajesh? Yes, definitely. Okay, let's help him. Okay, guys, you might be able to know the answers easily. Some people require some support. Let's help. Everybody will be able to understand that. That's why. Okay, so just wait for some time. Let me help him. Okay. See, Rajesh, if I assume these two diodes are on, for example, you get here 6.4 as the node voltage. But it is giving me wrong condition that I assume this part is on and this part is off, which is impossible because if you get 6.4 at this node, compulsory it will forward bias these three diodes, which requires only 2.1. If this voltage is less than 2.1, okay, my assumption will be correct. But 6.4 is more than 2.1, na? It is impossible to get D1, D2, D3 off. So this assumption is wrong. Okay, so if they are ideal in the reverse bias, the voltage must be negative, but they have a drop of 0.7, total 2.1 से कम होना चाहिए if you keep them as off. So I assumed off, but I got 6.4, which is contradicting. चलो let's go for the next question. Okay guys, आप लोग के लिए टाइमर resume कर रहा हूँ, try करो. Right. No, Arvind, I think some students are from Hindi background also because it is for TSSPDCL and other exams of the state government also. I can see some students who don't know, okay, Telugu. Otherwise, I can teach in Telugu separately, no issue. Okay, so fine, let's move. Okay, Rajesh, fine. Okay, please try this question यार. 13 minutes time दो. 13 seconds, 10 seconds बाकी है. सतीश ऑप्शन सी दिया. Okay. Yes, electrical. You can see the examination name. Every question will be having its examination tag. Okay, fine. So here also listen carefully. What happens? Assume diode is off. Okay, diode off में हमारा required condition is this V must be negative. A diode off में ideal diode को open circuit करते current is zero. What we need to check is this V is positive or negative. If V comes as negative, your assumption is correct. Okay, this is assumption only. Assume my diode is off. This process you can apply to solve any question of the diode, guys. If you assume diode as open circuit, reverse bias, then voltage across it must be negative. If you assume it as a forward bias, current, positive current should flow from positive to negative. This simple rule. Okay. Assume diode is off. Then 9 volts, 10K, 10K. Okay. Then 5 volts, 10K, 10K. Diode is open circuited. V. Okay, let's take this node voltage as VA, this node voltage as VB. Okay, what is your VA? By voltage division principle, this node voltage is a half of the total, 5 by 2, 2.5. What about VB? This node voltage is a half of the total, 9 by 2, 4.5. What is VAB? VA minus VB, minus 2. And what is the current flowing? 0. So my assumption is correct. So 0 and minus 2. If you assume it as a forward bias here, you should replace this with a short circuit and measure the current. Okay, that current should flow from positive to negative, but you get a negative current here. You can check it. Okay, you can assume it as a short and try it. You'll get the answer. Negative current will be coming. That shows your assumption is wrong. Okay, so if you want to try, you can try it at home. So what is the answer here is no current will flow and the voltage across it is minus 2. थोड़ा सा difficult, a little difficult question I'm taking. So let's see. It's not very difficult, guys. I hope you people can do it. If you are able to do this question, it's good. You people can be. This is a transco question given in 2012. Okay. Okay, fine. See here. The voltage signal 10 sine omega t is applied to the circuit with the ideal diodes as shown in the figure. The maximum and minimum values of the output waveform for the circuit are respectively. If 9 and 5 are interchanged also, in that case, it will be forward biased because you get 4.5 at this end. Na? Anil Reddy. Okay. Next. Just a moment. Okay. Yes. Option D is the right answer. How many of you have given that? Ideal Transformer, Gulshan, Ravindra. Very good. Okay. Option D, option D, option D is the right answer. Fine. Now, Anil, you can find the current by any of the methods like superposition. Okay. So the voltage signal, if you want at the end, I can solve in that way also. Okay. The voltage signal 10 sine omega t is applied to the ideal diodes. First thing, listen here. If D2 is on, if you make this diode D2 equal to on, if by chance, if the second diode is on, irrespective of the conditions, D1 is on or D1 is off, it doesn't matter. Always your output P0 is equal to plus 4 volt. Okay. If D2 is on, your output is always equal to plus 4 because you have a diode here. When this node voltage is greater than 4, this diode will be on. So this node voltage cannot be more than 4. First, this point is clear to everybody. See the option. He has given 7, which is impossible to happen. Here, can I get 7 volts here? No, sir, impossible. If you give 7, immediately the diode will be forward biased and you will get the 4 only. And the remaining network will adjust its value accordingly. So, whatever you do, this node voltage cannot be more than 4. So, I am showing you the easiest way to solve the question by eliminating the option. So, 10 volts is also impossible to happen. So the first thing is when the diode is on, your answer is 4. So positive voltage answer is 4. So this is fixed. There is no alternative. Next, if diode D2 is off, D2 is off. If D1 is on, okay, D1 is on, what is the condition you will be getting? This is a 10K and this is your VI. Okay, so let's assume this is on. Okay, when it will on, all those conditions we will discuss it, don't worry. And now this is 10K. Let me replace the diode with, I'll show you short circuit. Okay, and because the second diode is off, you can neglect this because it is an open circuit, you can neglect this part, and this is your voltage V0. Okay, so you can understand here V0 is equal to, this is your VI, right? Okay, so what is the current I here? I'll move this little so that you can watch it clearly. What is the current I? VI, okay, and minus of minus plus 4 by 20K. Okay, so what is the maximum you will get? But here VI is negative. Okay, assume VI is negative because when VI is positive, it cannot forward bias this. Okay, so VI is negative. What is the maximum magnitude of the current? I am not saying the current with respect to polarity. I max is equal to, what is VI max? It is 10 according to the question, plus 4 by 20K. That will give me, what is that? Minus 3.5. I am doing wrong somewhere. 6 by 2 now 3 milliampere minus 3 milliampere. Okay, so in that case, what is your V0 is equal to minus 4 plus 10K into I. Okay, 1 minute. It is minus 6 by 20 minus 0.3. So that will give you minus 4 minus 0.3 into 10 into 10 power 3 into 10 power minus 3. That will give me minus 7. Okay, just a moment. Listen, I'll explain a little clearly here with more clarity. ध्यान से देखो. So when this diode is off, okay, so when your input is a negative quantity, if it is off also, if both are off, yes, it is possible. When both are off, your output is same as input because no current will flow in the open circuit. Output is same as the input. But when input is more, input is positive. We are here. He is asking only the peak value. Now, when input is more positive, highest value is 4. When input is negative, sometime it may be off. When it is sufficiently negative, it will reverse bias this diode. That is when it goes more than minus 4, for example. At that time, when it is sufficiently negative, it will reverse bias, it will forward bias this diode. So forward bias may, what is the current you will be getting is this voltage minus this voltage by total resistance. That current into resistance will give you this drop. This plus this will give you the total V0. So you need the maximum. So find the maximum current because these are in additive because the current is negative in that case. So the maximum current you will get is 0.3 milliampere. The maximum voltage you get is minus 7. Anybody have any doubt? Feel free to ask me. Okay. So any query? No. Ravi, this session we discuss analog, networks, digital. Okay. So analog का 3 questions लाया, digital का 3-4 questions and remaining all are from network analysis. Okay. So is this question solution is clear? Very good. Anybody have doubt? Feel free to ask me. So कोई भी doubt नहीं होना चाहिए. I have taken the models like that. 2-3 questions if we solve, more number of questions you will be able to solve from the same model. Okay. Can I proceed further, guys? Is it fine? Is it okay? आगे चलेगा क्या? Right. Yeah, in that way we can say, Arvind, okay. If some current flows, it will be more than 4, so compulsory it will be minus 7. There is no other option. In that way also we can say. Fine. Let's move further. Okay. So now let's see the questions from digital circuits. Few questions are digital पे आएगा पहले networks करके. Okay. So let's do the network questions. आप लोग तो wait कर रहे हैं ना networks के लिए. You people are waiting for the network, so let me do the first network question, so then we'll come back for the digital questions also. ठीक है. Okay, so guys, try this question. Okay, please try this. मैं थोड़ा सा पानी लेता हूँ. I'm just taking some water. Try your solution. Okay. Shivani option B. Anil option B. Okay. I don't think option 2. Yeah. Option B may not be right. Okay. Cross check. Govardhan and Arvind option A. Last 5 seconds. Very good. So Arvind and Govardhan, right answer option A. Okay, option A is the right answer. Okay. So listen here. Here, first thing, कुछ नहीं specify किया. Assume it is additive. Okay, and try to solve it. If you don't get in the options, you may check for opposing also. So for this transformer coupling, what is the equivalent? You know, L1 minus M. This is your L1, this is your L2. L1 minus M is 4 minus 2. And this is, here the formula is L1 minus M. M. Here L2 minus M. What is my L2? 2. 2 minus 2, 0. And now we have another inductor connected. So what is the L equivalent? That's all. Okay. So what is the L equivalent here? You get 2. This is 2. And this is 0. And another 2. What is the L equivalent? 2 plus 2 parallel with 2. It is 3. Okay. Option this. Okay. Right. Yeah, Prabhu, mostly we can say and based on the previous analysis, we can say it's sufficient. But anything can happen on the examination. But agar, if you have attended my comprehensive course, I can definitely say that you can answer any question undoubtedly. That I can assure you, irrespective of the toughness. Okay, fine. Let's go for the next. Right, option 3, option 3, option 3. Right, next question. ये क्वेश्चन तो बहुत इंटरेस्टिंग है आई मीन दिस क्वेश्चन इज मोर इंटरेस्टिंग व्हाई इट इज इंटरेस्टिंग मींस बिकॉज द सेम क्वेश्चन इज कॉपीड इन गेट 2022 this appeared in 2015 means they gave first okay the same model copied in the sense they have given the similar not copied from this and pasted there okay so generally, GATE questions will appear in this exam. Okay, in any exam in India, few GATE questions will, as it is, appear undoubtedly true. But very rarely, GATE question is from the source. Okay, other source. This happens in for this particular question. Okay, so try this question. Yes, Monica. If you prepare for a GATE model, that is sufficient to answer these questions. You may feel a little easy also, no difficulty. So the inductor of the quality factor, you see GATE 2022 electrical engineering question paper may as it is same question appeared. Just values changed, that's all. Yes, 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 yes. So okay, fine. So here the answer for this question is 1 by q equivalent is 1 by q1 plus 1 by q2. Your q is equal to 10 into 100 upon 10 plus 100. Okay, 100 by 11. So conventionally, if you want to solve, it takes a little more time. You can take like this and start solving it in the Laplace domain. Okay. You can do some, we need to do some approximation when Q is high and all those things if you do it. Okay, omega L1 by R1 is 10. 1 by omega CR2 is 100. By using those concepts, if you take the total Z and find it, you will get the solution. It takes you 2-3 pages to solve this. Okay, so you can easily do it. Total Q in this particular case is, it appeared in GATE also 2022 page. Same question. Right. Let's move for the next question. So this is a TSSPDCL question appeared in 2015. I need you people to answer this. Yeah, I want you to answer this question first. Ready? Option C, option B, option D. Okay. Read the question carefully. Okay. Lakhs by 5. Right. Option C is the right answer. Who have given option C 100% right answer. First basic thing, listen here. In an inductor, this is the voltage across the inductor. This is the current in the inductor. Always you have 90 degrees phase shift between the voltage across the conductor and current in the inductor. Current lags the voltage by 90 degrees. Okay, current is voltage is going ahead of current. This is true for a pure inductor. Now in a single phase RL series network, RL series network may the current in the supply voltage lags the current I. This is the current I, because see here, if you take a RL circuit, the current I in resistor, inductor, total current also same or not? Your IL, IR, I, whatever may be same, because okay, RL series circuit. Okay, this IL and IR same. The current lags the voltage, okay, the supply voltage by, so the supply voltage will be something like this, right? What is that voltage? 5. Okay, this is lagging this by 5. Okay, so the current lags the voltage by 5. The voltage inductor and the voltage is across the inductor. So voltage across the inductor क्या कर रहा है भाई? Lead. Okay, so if you see these two, VL leads the supply voltage by, what is that? Total is 90. This is 5. What about this one? 90 minus 5. Got it? Otherwise, I'll say like this. You see, this is the supply voltage. The current I, which is equal to IL, lagging behind by 5. And this voltage across the inductor. Okay, this will be total 90. Okay, this part is 90 minus 5. Total is 90. So this part is 90 minus 5. In that way also you can say any method will give you what is the answer. It leads by 90 minus 5. Okay, क्या हो रहा है शरण? Thank you. What's happening? The same comment coming. Okay, छोड़ दो. Let's continue. Okay, so fine. Read this. You just concentrate on the lecture. Okay, guys. Fine. So this is another question. I think it's a very simple question. I hope you people can be do solve it easily. Just less than 1 minute. So I am giving you just 40 seconds of time. Yes, just read the question and answer it. Okay, fine. Okay. Okay, leave it, Arvind. Just concentrate in what we need, and that's all. No need to worry about it. Okay, fine. So last 10 seconds, guys. Very good. Option C. This question, I think 99% of you people can do it. It's a standard. It is given 2019 only. Okay. It's a standard question from network analysis. That is nothing but source-free RL circuits. Okay. So here the switch is here for enough long time means it is at steady state just before the switching action. Network is in steady state. Okay. Leave this. We replace inductor with a short circuit. Okay. So here the current in the inductor IL of 0 minus. What is IL of 0 minus? 50 by 10. Inductor current cannot change instantaneously. Now if you move the switch here, this will become source free for t greater than equal to 0. For t greater than equal to 0, this is a short circuit and this is the 10. So current source of 5 parallel with the inductance of how much point? We need not do all these things because it's an objective question. What is the time constant? L equivalent by R equivalent, that is 1 by 50. So IL of t equal to I naught e power minus t by 2. Okay, directly here itself we can stop. You know, L equivalent, R equivalent 0.2 by 10, 1 by 50. Okay, 5 e power minus 50t. It's a source free RL circuit response. Okay, great. Chalo, let's go for the next question. Okay. I think they went here. Suddenly some group came and they commented, they went, I don't know what happened. Okay, no issue. Next, in the same way, one more question from network analysis. The network is your fort, guys. You should not what we call lose any marks. Okay, don't do any silly mistake. Don't commit any silly mistake. This is the point where you can score the maximum. Okay, so don't miss it. If you give enough concentration, you can score the best. Right, give a try. Yes, yes, yes. Okay, okay, Siddesh. Anything can happen in YouTube. Okay, no issue. Let's continue. Okay, option A, B, C, D, 100, 25, 50, 60. So tomorrow also I'm continuing, guys. I'll take series of classes for you guys. Tomorrow I'll take the same session again. Okay. I mean similar, one more session I'll plan tomorrow. Okay. Okay. I think many questions are solvable within less than 1 minute. Many of you people are commenting the answers immediately. Here, one important thing you should observe. 10 angle 30 degrees, V also 100 angle 30 degrees. What is the phase difference between voltage and current? The phi will be equal to 0 degrees. Voltage is 100 angle 30 degrees, current is 10 angle 30 degrees. The phase difference between V and I is equal to 30 degrees. The phase difference between V and I equal to 0 degrees. And so V comma I in phase. Okay, your omega equal to omega naught. In series RLC, what is the required condition? My XL must be equal to XC compulsory for the series RLC. Normal case mein imaginary part must be equal to 0. So because it is series RLC, imaginary part XL equal to XC. Right, unity power factor. So what is XL? Omega L. What is XC? Examiner has given the reactance value 10. What is your L? 0.1 into omega equal to 10. Omega equal to 100. That's it. Omega is equal to 100 Hz. Got it? Fine. Right. Option A. So let's move for the next. Okay, this is the question which appeared in APEPDCL 2019 paper. Let's see how many of you are able to do it. Okay, so the same question is there in GATE 2003 also. It is as it is copy paste as 2003. The GATE paper linked question appeared for 4 marks. In that one question is this one. Just a minute. Yeah, 100. 1 minute. Yeah. Yeah, 100 radians per second is correct. Then 100 by 2 pi kitna? 1 minute. 1 minute. Maybe galat kiya kya? Just a minute. Yes, Siddesh, perfectly correct. Calculator open karo. 100 by 2 into 3.14. Yes, 16 is the right answer. Yeah, maybe galat kiya. Omega is 100, but examiner asked F na. F equal to omega by 2 pi. 100 by 2 into 3.14. That will give you 16. ये होता है सिली मिस्टेक. मैंने आपको बताया, मैंने किया सिली मिस्टेक. Okay, so 16 is the right answer. Be careful. Right. Radians per second, but examiner asked in Hz. I haven't seen that. Okay, I'm sorry. So answer is option D. Who has given option D earlier? Anil Reddy, I think. Yes. Teza also given right answer. Fine, thank you. Chalo, let's move for the next. Try this question. Give a reading first. A coil of inductance 40 ohm is connected as shown in the figure after the switch has been in contact at point 1 for a very long time. Okay, and it is moved to point 2 at time t equal to 0. Okay, at time t equal to 0, the voltage across the coil is 120. The value of the resistance R is last 5 seconds, 4 seconds. Teza given the answer as 40. Any other answers? Okay, let's see. I feel the answer will be 100. 100 is 60. Yeah, 40 might be the right answer. Okay, fine, guys. Let's do it first. At time t equal to 0 minus, because the independent source connected to the network for a long time, my network is in steady state. So what's my input? 120. This is 20. This is inductor and 40. You can replace the inductor with short circuit. Okay. So what is the current I? 120 by 60, that will give you 2 amperes. This is the inductor initial current, I of 0 minus, which is equal to I of 0 plus also. Now at t equal to 0 plus, okay, you have which moved to the second position. That is, now you have R, and this will be 20, and this will be 40, and the inductor can be replaced with its equivalent current source of, thank you, current source of how much its initial value parallel with the open circuit. What is that current source value? Initial value of 2. So this will be 2, this will be 2, 2 and 2. Okay, so now, so here examiner has given that the voltage across the coil, you understand here inductor is delivering the energy. When it is delivering the energy, its current direction should be negative to positive. Compulsory, its voltage should be negative. So if you take this VL, this is minus 120. If you take, it is perfectly correct. In this polarity, it should be 120. Okay, it cannot be in the reverse it because it is not absorbing the energy, now it is delivering the energy. Okay, so please understand, he said across the coil includes this resistance. Don't differentiate between the coil and I mean inductor and resistor here, because he has given in the question the coil of inductance 10 Henry and resistance 40 ohm. 40 ohm is part of the coil here. So this total together is 120. Now this is 2R. This is 40. So what is the drop here is 120 is equal to 2R plus 40. Then 80 equal to 2R. What is your R value? 40. Just KVL. Okay. You apply KVL, you will get this. Okay. R will be equal to 40. Here the catch is this total is 120. Don't take this part as 120, and the polarity should be taken reverse. Okay, because with common sense it is not absorbing, it is delivering, because there is no other source present in the network undoubtedly, because all of them are in series. Initial inductor current cannot change instantaneously. 0 plus may all the element currents must be same. You should take. I replace inductor with open circuit at 0 plus. Okay. I hope the solution is very clear for you. Any kind of query, feel free to approach or ask me, no problem. Yes, right? Okay. So if you take, okay, this as 20, and here you should specify this as 20 ohm. In that case, what happens is, let me try in that way also if you want. That total will be 60 in that case. Okay, this will be 20. Okay, in that case also you will get the same answer, because okay, otherwise outside the 40 you have 120. Just a moment. Mm-hmm. 240 is 80, 220 is 40. In that case, this part itself giving 120 na, so this part cannot give, this should give 0. R should be 0 in that case. Okay, that option is also available. Okay, but 1 minute. Just a minute, guys. I'll show you the different way to solve this question. Actually, because it is a GATE question, I know the equivalent. That's why I have edited the question. If you don't edit the question also, I mean, I have taken this 40 as the part of the coil. Okay, but because he has specified the coil with 10 ohm, he has not shown. Actually, if you want to show, he should show this as another 40 ohms here. Then it is fine. But he has not shown that. That's why I took it as a printing mistake. So if you don't take it as a printing mistake, suppose because I haven't seen the paper, 1 minute. Just a minute, we'll do the next page. $120. Okay, 1 minute, guys. Suppose if question is like this, we should assume if this figure is 100% correct. Suppose if it is given like this, undoubtedly 40 is the answer, no doubt in it. Okay, because 40 should be part and parcel of the coil. Suppose if examiner gives like this, he said the coil is having a resistance of 40 ohms. In that case, okay, because the original question I don't know what in gate question they have given in this way only. In that case, we should replace inductor with what is that? Then inductor initial current will vary now. Let me try. Inductor is replaced with a short circuit. What is the internal resistance of the inductor? 40 now. So let me try. 40, 20. This is 20. 120. What is the current I? 120 by 80. Okay. 12 by 8, 3 by 2, 1.5. Finish. Okay. Now T equal to 0 plus. This resistor is there. This is 20. This is 20. And we replace the inductor with 1.5 and open circuit, and you have a coil resistance of 40. Okay, suppose this is true. This must be 120 according to the question at t equal to 0 plus. And this current is how much? 1.5. This current is how much? 1.5. So this drop is how much? 1.5 into 20, 30. This drop is 30. And this drop must be, because forcefully if it is 120, 30, 30 according to KVL, VR is equal to, by KVL, if it is 60, 120, this should be 60. Your R must be equal to 60 by 1.5. Same answer. Okay. In that case also 60 by, because this voltage by resistance will, current will give you the resistance, 60 by 1.5 will give you 40. Any method will give you same answer. But actually he should specify externally 10 Henry comma 40, then only it is true. That's why I have modified this. In this way also if you solve it, okay, you will get the same answer. If you assume this is correct, okay. Examiner has given this figure or this figure, not sure about it because printing mistakes to ho sakte. That's why I have taken in that. Okay, right, because I have taken the source of GATE 2003. Okay, right, chill. Right. Let's move for the next question. Yes, this one. I will check. Okay, Rajendra. When is that exam? NPDCL. माइक्रोप्रोसेसर का क्वेश्चन सॉल्व करने के लिए आई डोंट हैव एनी प्रॉब्लम बट I haven't taken the concept earlier. That's why, I mean, for you people, I haven't explained the concept. Because of that, I think you people might feel disconnected. If you don't have any problem, I am happy to solve it. So tomorrow I'll bring some 5-6 questions from microprocess. I'll try to bring the questions like that, which can explain you the concept also. Okay. 14th August, na, before that, definitely I'll plan. We have more time, na? So I'll plan for it. Okay. Yes. Okay, guys, try this question. ये तो बहुत लंबी क्वेश्चन है, लिटिल लेंदी क्वेश्चन. मैं तो कुछ शॉर्टकट्स भी अप्लाई करके चेक किया, सभी फेल किया, ऑप्शंस भी ऐसा सेट किया एग्जामिनर इन दिस क्वेश्चन. प्लीज रीड प्रॉपरली. Option D is right answer. I don't have any technique here. So we need to solve all ZA, ZB, ZC and find the final answer. Okay. So you know the what we call star to delta formula, right? I mean, actually, I try to. What happened is first to apply the shortcut, I thought of doing like this. Only find the real part and eliminate the option. But real part में भी दो tens आया. Or only find imaginary part and see the eliminate the option. Though J5 J15 आया. So there is no alternative. I need to so we need to solve here for total. Okay. So listen here. Because he is asking which of the following is not equivalent. So for ZA, what is the answer? For ZA, okay, sum of the nodes plus their product by remaining. So 10 plus J5 plus 10 by 2 is J.5. 2.5. Okay, because 50 by 25 by 2, 2.5. So 10 plus J 7.5. This is a wrong answer because it is there, because he is asking not there. What about your ZP? Just sum of the nodes 20 plus J5 plus 20 into J5 by remaining. So 20 plus J15. Okay, so you can eliminate this also. Lastly, ZC. Okay, again same. Product sum of the nodes. What is the nodes? If you see ZC, 10 plus 20 plus their product by remaining. 30 plus J 40. Okay, and it is in the denominator, so minus J. So option D is the right answer. Here wrong is the right answer. Okay, nothing great, just directly apply star delta, but don't do any calculation mistakes. Right. Yes, you don't hear the examiner question is it is neither ZA nor ZB nor ZC. It should not be equivalent. In that case, we need to find all of them. That is the trick here. At least we can try to eliminate by calculating only real part, but he has given the real part also not, he has given same in two options, imaginary part same in two options. We left with no option here. Okay, chalo. Right, networks का questions तो हो गया. So let's go for yeah, digital ka 3 questions I brought, not much questions. We'll finish and we can leave the class. Try this question. It is a previous GATE question and given in one of the examination of your transco. So guys, keep attending the classes sincerely. I'm happy to take any number of sessions for free, undoubtedly. Okay. So based on by seeing you people, I'll get more energy to deliver more and more. Okay. So based on your response, your sincerity, मैं तो first session पे देखा comments I read and I felt that okay, we can help for more number of sessions. So keep my motivation on just by showing your sincerity, nothing else. आपका sincerity दिखाओ, मैं तो हमेशा happy to help you guys. So options A, B, C, D. What is the right answer? Okay. Come on. Time up. For the circuit shown in the figure, the Boolean expression for the output Y in terms of the input PQRS is. Okay. So we need to find with respect to PQR. Firstly, you know, one simple technique to simplify these kind of questions is send the bubbles back. Okay, how to send the bubbles back? I will show you. Firstly, you can replace this with a bubbled R. This one also with a bubbled R, such that more number of bubbles will be cancelled. By De Morgan's law, NAND gate is equal to bubbled OR gate. So by using that concept, cancel this, and so on. Okay. So here it's nothing but P, Q, R, S. Here what you get? P plus Q, R plus S. It is as it is. P plus Q, R plus S. So here just OR operation. P plus Q plus R plus S. Within 1 minute you can solve the question. Okay, very simple. Right, right. Fine. What is the simple technique here? NAND by De Morgan's law. NAND is equal to bubbled OR. Right. So copy that. Yes, Arvind. I think they left here. Okay. Fine. So this is the technique, sending the bubbles back. We can solve the complex digital circuit easily. NAND is bubbled OR, NOR is bubbled AND. You can also use the concept of two-level logic. NAND is equal to AND OR, NOR is equal to OR AND concepts also fine. Okay, one more question. I think for you people, I discussed with Sharma sir also. Maybe sir is also willing to take. He said that he will be taking one session for you for general intelligence or something like general aptitude. You have some 30 marks part is there, na? That also sir will might take some sessions before 17th. I'll update you once sir confirms it. So this question I don't think इतना time भी नहीं चाहिए यार. 10 सेकंड तो ज्यादा है. So how many number of 2 by 4s required for making 4 by 16? Take this 4 and 16, just divide with this, you get 4. Divide this with, you get 4. 4 plus 1, total is 5. Okay, until you end up with 1 or less than 1, we should continue this division. Take this 16, divide with 4. You get something now, that you take it and again divide with the 4. Okay, this is what we need to do. Next question. So you need microprocessors. Tomorrow also we do all the subjects including microprocessor. Right. Try this question here. A switch tail ring counter is made by using a single D flip-flop. The resulting circuit is. Okay, तो भी theory का question. Just 2 minutes here we can leave maximum. Not much time of yours required. These are the questions where you just read and you can answer it. Okay, try. Option. Time up. A switch tile ring counter. Switch tile means twisted tile. Johnson counter. Johnson counter में क्या होता है sir? If you take D here, Q here, Q bar here, this Q bar will be going as the input to the clock. This is called switch tile ring counter. Okay, it is made by using a D flip flop. Complement of Q is going here back. What is the resultant circuit? If the complement of Q is going back, the resultant circuit is what? Every time you apply, your Qn plus 1 in the D flip-flop is equal to D. But what is D here? Q bar. It always toggle. So every clock pulse it will toggle. It is same as D flip-flop provided T equal to 1. Okay. This is a switch tail ring counter is nothing but the Johnson. Instead of Q, we connect Q bar as the input. Okay. Fine. Next question. I hope, yeah, we are done with the number of questions. So for today, these are the questions I want to discuss with you. Okay, some 3 questions from this one, analog, and 2 questions from 3 questions from digital, and baki the network ka questions. Yes, that's all for today, guys, from my side. So these are the new batches going to start. Okay, on Plus, you can use my code and subscribe to Unacademy, and you'll be getting the 10% discount. These new batches are going to start from this Thursday, that is 14th. Okay, so these are the batches. Lakshya and Pragati batches are going to start for 23 and 24 aspirants. Okay, so this is my code you can use for Unacademy subscription. These are the prices where you get 10% discount on the subscription. Okay, so and here you'll get the printed notes. Okay, so from July 14th, comprehensive course of mine on analog circuits is going to start on Plus for those who are in the Plus platform. I'll be giving you the in detailed course. We will be discussing as easily as possible such that you'll enjoy the process of the learning. Okay, so you will be getting printed notes chahiye to. This is only for already existing Plus and iconic subscribers. They can use this code and they will get 10% discount on the notes. Okay, and this is the exam going to happen on this Sunday. If you need some scholarship on Unacademy subscription, you can write this based on your subscription, your ranking, you will be getting the discount. You can use the code Shankar10 to enroll. That enroll link is available in this video description, you can see. So this is what you get for what we call Unacademy books of electrical and EC books. Okay, this way you will be getting 10% discount. We have the doubts educators available for you. Okay, you can ask a doubt and you can get it solved. Right, so Unacademy Lite is for test series. You can try this also. So thank you very much, guys. Any queries? Anybody? SSC JE is there, electrical engineer. Okay, so fine. I hope we can end the session for today. Tomorrow, same time, 9:30 p.m. We'll meet again with one more exciting session. Okay. Thank you. See you all. Good night. Love you all. Bye bye.